we'll do a 9, I think it's 9, 12, 13, 14, 15. So number 9, we got this region. It's again bounded first quadrant. A lot of times they put it in the first quadrant. It kind of simplifies it. The bounded is important to kind of note that you're dealing with those fences. And then they'll give you graphs that are really easy to kind of identify. Like that's what x cubed is. You should know what x cubed is. We got the vertical line x equals 2. So going out here, x equals 2. And the x-axis, so you're dealing with this region right here, revolved around the x-axis. So the volume is equal to the integral from 0 to 2 pi. This is the radius. Remember, now here's the radius that we're talking about. So with that radius, we have pi times the radius squared dx. And then you're just doing an algebra problem almost at that point. I mean, you got one more calculus step to integrate this. I'll put pi on the outside just because it's easier to deal with. Just know that it has to be multiplied at the end. This is going to be x to the 6th dx. So you got pi times x to the 7th over 7, evaluated from 0 to 2. And now you know you have pi times 2 to the 7th divided by 7. And you should know that that's this one. I mean, there's only one choice on that's really going to make any sense. So hopefully that helps clear that one up for you. Let's go to number 12. This one looks a little bit more complicated, but we just have to kind of get in mind what we're doing here. We got the region enclosed by this graph. This is a quartic graph and if you're like, well, what does that look like? Anything that to the power of 4 looks like an upside down parabola. Okay, so going a little further, got a horizontal line, y equals 3/2. The x coordinates of the points of intersection of the graph are x1 and x2. x1 is less than x2. That helps you kind of identify the bounds. Which of the following gives the volume of the solid when revolved around the line y equals 3/2? So what you kind of need to know is you're going to have some sort. You got y equals 3/2. And it really, I mean, it kind of doesn't matter if you don't know where this thing is. It doesn't necessarily matter. Knowing that you got some x1, x2 thing, and you know it's an upside down one, so you know it's got to look like that, otherwise they wouldn't even intersect. Because it's only bounded by those two graphs. So it's, it's some kind of region like this. It has to be bounded like that. And if you're revolving this, around this axis, you're just dealing with one radius. There's no hole on this if you're going around that. This is 3/2. Now this is the graph of 5x minus x to the 4th. So you got pi times the integral from x1 to x2. And you got the top curve minus the bottom curve squared dx. And if you answer that question, there it is right there. The answer. The first one is an easy one to miss. If you forget about that darn pi, you'll answer A, and you won't even get down to C being the right answer. And and that's a shame if you get there. You can't forget the pi in there. All right, so let's keep going here. Oops, I have to scroll out a little bit on this. Okay, so let's look at 13. We got another region bounded by this graph, the horizontal line y equals 2, the vertical line x equals 1. You're going to evolve this around the vertical line. Notice that everything is in terms of y. You know that this one is not the answer because it's not in terms of y. You're revolving around the line x equals 1. So you know that you're dealing with a line that looks like this, y equals 2x minus 2. And that's just a line that has a positive slope of negative y-intercept. You got the horizontal line y equals 2. So when y equals 2, you got a horizontal line, y equals 2, and you're revolving it around the line. You got a region and the vertical line x equals 1. When x equals 1, y is equal to 0. So you know that is when x equals 1. Because when x equals 1, if you put 1 in there, you get 0. So you know that's what you have, and you're revolving this this region, and here's the region that we're talking about. It's this region right there. That's the one that is bounded by those three graphs. And so then if we're spinning it around this region, we're dealing with it in terms of y. So we got pi. I'll just pull the pi out in front to begin with. That's what they did. We're going to go from 0 to 2. And then we're going to have the top curve minus the bottom curve, because the only radius we're talking about on this is this. This is our radius. So we're going to put the radius squared dy. We got to come up with that radius. Well, notice that if we solve this for x, this would be y plus 2 divided by 2. And now we would do the top curve, what essentially is kind of like the top curve if you turned your head sideways or turn your screen sideways. And then minus 1 squared. And so if you get that, kind of looking at this, notice that this one is from 1 to 2. That's the wrong bounds. So you know, when you look at those first two, those two are pretty close. You look at them, they're the same thing, only this one goes from 0 to 2 and 1 to 2, and you kind of got to deal with that in the appropriate way. So hopefully that helps. Let's look at 14. 14 here. Okay, now we're in the second quadrant. They give you this thing. Here's clearly a line. Here's clearly that natural log one. The graphs intersect at a and 0. Which of the following? So this is some value a, x equals a. Which of the following gives the volume of the solid when it's rotated around the line y equals -1, which would be down here on this graph. So you kind of look at it, and we're going to go, got this line, got this, pretend this looks the same. But that's what we're doing now. We're spinning it around there. So we're clearly going to have pi. We're going to have the integral from a to 0, because that's this region that we have right here. This region right here. This graph down here is y equals -1. So our two radii on this one, this is our big radius. This is our little radius. So we're going to do the big radius, which is the line, negative x, minus the small, or the top curve minus the bottom curve squared, minus the top curve, which is this x squared, natural log of 1 minus x cubed, minus negative 1 squared dx. Okay, so that's what we're going to have. We'd have to find out which one that is. Notice they do a plus here. It's looking a lot like that one. I think, you know, these two are close. This one doesn't square it, so that's bad. This one squares the whole thing. That's not good. That's what this one is doing. This one is squaring it and squaring it. Let's see the difference between these two. Notice this one has a little missing a negative, so this one down here is going to be your answer. All right, last one. Question number 15. Let M be the region in the first quadrant bounded by this graph, this line, and the vertical line x equals 3. Find the volume of the solid generated when it's revolved around the horizontal line y equals 1. So you want to kind of get an idea of what these graphs look like. Notice you have one that has a y-intercept of 2. Both of them have a y-intercept of 2. One has a slope of 1, one has a slope of 3. So it's kind of like this. You got one that this would be y equals x plus 2. And then you got another one, y equals 3x plus 2. What else are we bounding this by? The vertical line x equals 3. Oops. Do that in the wrong place. Something like that. So the region that we're talking about here is this region. That's what is bounded by those three things. Okay? And we're going to revolve it around the line y equals 1. Y equals 1 is below those things. So y equals 1 is here, and we're going to go around this axis. So if we're doing this one, I'm going to kind of go here and say, okay, what I have, this graph here, I'm going to do pi times the integral 0 to 3, because that spans this region, 0 to 3. And now we got two radii. We got this one, that's our big radius. This one, that's our little radius. So the big radius is 3x plus 2 minus 1 squared. And the little radius is the top curve, which is x plus 2 minus the bottom curve squared. And now you have to actually go through and solve this one. This one's a little tricky to solve. You know, if I was going to tell you how to solve this one, you see that I have the same thing that they have here. They do a little simplification, and then you have to multiply everything out and do all the work with it. Here, I'll do that. I'll try to do that really quickly here for you. But what I would do on this is I'd say, okay, now I have this pi. I'll keep that out there. I'll deal with that in a second. The integral 0 to 3. 3x plus 1 is 3x plus 1 minus x plus 1 times x plus 1 dx. Continue this on. 0 to 3 pi. 9x squared plus 6x plus 1 minus x squared plus 2x plus 1 dx. Simplify this a little bit. 0 to 3, 8x squared. So I'm going to have to distribute this negative through. Plus 4x dx. So the negative one, the positive one goes away. So this just got a lot easier. Got 8x cubed divided by 3 plus 4x squared divided by 2, evaluated from 0 to 3. Don't have to worry about the 0. We got 8 times 3 cubed divided by 3 plus 2 times 3 squared. Good thing about that is this is 8 times 3 squared plus 2 times 3 squared, and then you could simplify this a little bit further where you have, this is 72, and this is 18, and that's how you get 90 pi. So there you go. That's how you do that one. Hopefully this helps. If you have questions, let me know.